Okay, so within this lesson, we've already talked about radical equations. We have also talked about fractional equations. What we want to look at is we want to look at a system of 3 linear equations. So that's what we want to look at with this type of problem here. Right away, you're checking to see if it's the same one in the homework assignment. I don't know. I did not get it from the homework assignment.
No, X minus 2y.
No, it is not the same as either one in the homework assignment. But after we work through one, we might be able to look at one in the homework assignment. So I don't know. I got 2 examples, and then maybe we can look at 2 more examples. So as we look at this, when you see a setup like this, what do you think of? Elimination or substitution. You're going to do the same thing, but when you eliminate or substitute, you're only working with one variable at a time. So if you choose to pick one of the equations, you would either, I'm guessing, maybe pick, if you're thinking substitution, pick the top equation and solve for x. You're left with a y and a z. And if I put that in place of x here, I'm going to have a y and a z, and then I also have y's and z. So now my equation, the red equation, becomes all values with y, z. And same thing with the green. It becomes, if I replace that x with what it's equivalent to in terms of y and z, I have 2 equations now, which would be the red and the green, that would have y's and z's. And if I have 2 equations with 2 unknown values, I can solve. You notice that right now we have 3 equations, and you need 3 equations to solve because you have 3 unknown values. Method of preference, elimination, or substitution when you usually encounter these problems? Either or. We're really flexible.
I feel like substitution would be easier with this one.
Maybe not. Okay, here's where I struggle trying to present this, is because there are so many different routes you can take. It's as you look at it, what do you see? And then I can tell you, yes, that's correct, or no, that's not correct. But there's a number of different ways to solve this. So as I stand up here and show you one method of solving it, it doesn't mean that, oh, I always have to take the first and the second equation and eliminate this variable first. It's not. So you've got to think through it, visualize it. If you want to say, well, I would like to do this first, can I do that? And I would say, yeah, that's great. If you compare your x, y's, and z's across all 3 equations, do you notice anything in particular? Or what do you see? There you go. The z's all have the same coefficient, and one of them is an opposite sign. So did anybody else notice that right away?
Yeah.
Ladies? Boys see that? If I just focus with those 2 equations, if I recognize that, let's just look at the black, or the first equation, and the second equation. As I look at those 2 equations, what do you notice happens? The z's cancel. I can perform elimination right now on those equations. If I perform elimination, the z's drop out, and what are you left with? 3x plus y equals 4. Which colored equation out of the original ones, black, red, and green, have I not used yet? Green. I now want to take the green equation and reuse either the black or the red. Probably the red. Why would you say the red? Because the red is negative z. So if I go back and I look at those equations now, I have 2x minus y minus z equals 0. And I have 2x minus 2y plus z equals 1. As I glance at those, some of you, that x stands out in front of you because it's the first thing you see, the first term that you see. And you're like, well, maybe I could cancel those x's. Let's take the bottom one times negative 1. But if I were to do that, take the bottom one times negative 1, it changes all those signs. You get y minus 2z equals -1. But what can you do with those two equations? Nothing, because I still have, one has an x and a y and the other one has a y and a z. So to lead you to that, they're pretty nice with this first example that I put up here for you. Let me get rid of those signs that I changed. Where did that go? Okay, I'll just do this. 2x minus 2y plus z equals 1. They're pretty nice with this first equation, or this first example they give you, because the z's drop out again. And that's what you want. You want to eliminate the same variable when you use that third equation and you're working with the elimination substitution. Because if these z's drop out, you are left with the equation 4x minus 3y equals 1. Now you want to focus on the two purple equations that I have generated. They both have the same values in them, right? Variables. I have 3x plus y equals 4, and I have the equation 4x minus 3y equals 1. Now does that look like something you're used to seeing? Yes. So what we want to do from there is go ahead and do elimination substitution. Would you eliminate? Take the top equation times? I would just multiply the top equation by 3. That's going to give you 9x plus 3y equals 12. And the bottom equation is 4x minus 3y equals 1. So the y's cancel. And what do we get? 13x is equal to 13. So what is x equal to? 1. So x is equal to 1. If x is equal to 1, where do I go to try to figure out what y is? Now you could put it into one of these two equations right here, the two magenta one. You can put it into 3x plus y equals 4, or you could put it into 4x minus 3y equals 1. So if I put 1 in, which equation do you prefer? Let's use the top one. 3 times 1 plus y is equal to 4. So y is equal to 1. Now how am I going? That's not it. We had 3 variables, x, y, z. So now I need to figure out what z is. Okay, we can put it in the black one. You could put it in any of them. Keep in mind, you could have put x into one of these 3 original equations, actually 2 of them, and then you would have equations with y and z, and then you could do elimination and substitution again if you wanted to. But I think that's more work. So if x is 1 and y is 1, z is also going to be 1 in this case, because you get 3 plus z equals 4. So z is equal to 1. Now, before when you were doing this, they're linear equations. That means the graph of them would be a line. And before, what we had was an intersection point. You are used to just an xy coordinate point. When you get into 3-dimensional, you get an x, y, z coordinate point. So in this case, x was 1, y was 1, and z was 1. You could say your answer is 1, 1, 1. It's a coordinate point. If you look at an x, y, z axis, what that looks like, there's x, y. Where does z go? Right out to you. So you would, if I wanted to graph that, get my hands right here. Sorry if they look slanted. You would go x1, y1, z1, and it would be a point right here. 1, 1, 1. What? Oh, for you guys, sorry. I was looking at it for me. I went negative for you guys, sorry. There's positive for you, and positive for you. So it'd be right here. That's the XYZ they're talking about. But from, I mean, I could stick a pencil anywhere through here and create a line, right? So you get XYZ values. It takes practice trying to hold them on. So multiple ways. You could have done substitution right off the bat if you wanted to. There's just so many approaches you can take. It makes it very difficult because I don't want you to think that, oh, I have to do this, I have to do that. It's just how you see it. Are you ready for another example?
Yeah, you want me to give it to you?
No, I got it covered right now. Maybe the next one I'll ask you for an example. You think you could generate 3 equations?
Yeah, I got like 2 on top of it.
You got 2 in mind that you're just dying to work through? 2x plus 2y minus z equals 14. We have another equation, 3x plus 3y plus z equals 16. And then I have a third equation of x minus 2y equals 0. I will give you, I'll give you a minute to visit with a partner about how you think or what approach you would take to solve that problem. Let me look at where I'm at on my time on here. All right, you're going to get a minute. Actually, I'm going to post this, so you might get a little bit longer than a minute. If you want to try it with a marker, go ahead. Go through an approach while I say this.